computer. These integrals are hard.
Yeah, they're crazy hard. Like, I don't think, I mean, I get everybody wanting to stop cheating. I totally get that. But, like, nobody wants this situation we're in right now anyways. So this is crazy difficult. But, yeah, anyways. Okay, so it's 5, and the class time is actually done like 8-ish, right?
Yeah, it's like 5 or 6:30 or 6 to 8.
Okay.
Or 6 to 8:30.
Okay, so essentially 5 to 8:30 we have to do the test. Thank you.
And speaking of integrals, I believe that at 7 o'clock on, if you have it, on Sportsnet, they're going to be broadcasting the Dodgers inter-squad game.
Oh, okay.
So that's perfect integration time. Boring ass baseball. Just okay. So if you remember back in Math 180, we have this. We did something like this where you had A and B. That's X and that's the Y. And this might be the function. Now, what we're going to do is we're going to revolve it around, okay? And we'll get something that looks like this. Okay, now what we looked at in Math 180 was what was the volume, okay? Now what we're going to do is consider the surface area and see if we can get anything with that, all right? Okay, so our goal here is to find the surface area of the, I guess, revolved surface. Okay, so let's kind of look and see how we're going to do this. So obviously we're going to partition up, you know, and we're going to do some stuff here. And so like if this is an xi minus 1 and this is an xi, okay, and let's say that the function does this. Okay. All right, so when I revolve around this, I'm going to get something that looks like this. Maybe a little bit down further. Did you get the idea? Okay, now this thing that we've got, it's like a coin, right? That has a weird like rim to it. You know what I mean? Like if we turn this and looked at it head on, it would look funny. Okay, so what we're going to do is we're going to approximate helicopter again. Okay, we're going to approximate this shape with a shape which is called a frustum. Okay, so what a frustum is, it's if you have a cone and you lop off the top of it and you get like the base of a pyramid or something, of like the step pyramid or something like that, okay? This is what we call a frustum, all right? So now, how do we get the area of this frustum? Well, let's see if we can get the area of a cone. Okay, so imagine that I've got my cone right here. If we can figure out the area of the cone, then we can just subtract big area minus small area. Okay, so let's see, I got my cone. It's going to have a base down here like this. It's going to come here like this. We're not saying that there's going to be a lid on it. Okay. And the, you know, the frustum actually looks like this. It's like, you know, three-dimensional. Okay. All right. So if we were to, let's say, call the base radius r, and then this length we'll call L from here to here, like that. Okay, so these are the parameters that we have. We have the slant height and we have the radius. Okay, now what we're going to do is we're going to cut this thing like our snow cone cup, and we're going to flay it open. Okay, and so when we do that, we're going to get something that looks like this. All right. All right. Now, if we cut it and then open it up, it's going to look like that, not drawn to scale. Okay. Now, this length is still this L. Okay. Now, how far is it from here to here along the curve? Well, what is this top portion? That top portion is this circle that's down here at the base. Okay. And that's 2 pi times the radius. That's the circumference. Okay. And now there's this angle theta down here. Okay. Now this angle theta was nowhere in the original cone. It just kind of showed up. Okay. All right. So how do we find the area of a wedge of a circle? Like, let's say I took this is a pizza, and I want to figure out the area of this pizza. Okay, so if it went all the way around like that, the area would be pi times its radius, and its radius is this L number. Okay. Now, if we are going to be doing a portion of this, the area is going to be theta divided by 2 pi times this pi times this L number. Okay. So pi times the radius squared, pi times the radius squared. And so what we get for the area of the cone is going to be this 1/2 theta L squared. Okay. Now at this point, we need to dump theta because theta is nowhere in the cone. Okay. And then just to give you a heads up, what we're doing is we're figuring out how to find the surface area of this cone. And then to get this area right here, we would take the whole minus the top, and that would give us the area that we want. Okay, so now we're needing to dump theta. Okay, so let's see if we can do something about that. We know that for a circle, the arc length, 2 pi r, is equal to L times theta. Now you probably remember it like this. Like if this is theta and this is the radius and this is S, then S equals R theta when everything is in radians. Okay, so now these are our variables. So this means now that theta can be dumped, 2 pi r divided by L, right? So when I plug that in, the area of the cone is going to be the 1/2, and then the theta, which is 2 pi r over L, and then the L squared, which is going to be pi times r times L. And these are all parameters that we have. Okay. Okay, so in order to get the area of the frustum that we want, I need to turn the light on. Hold on a second, guys. I opened the window. Okay. All right, so that is what the area is of the cone. All right, so now let's figure out this frustum thing. All right, so I'm going to have this cone thing coming down. It's not going to be a part of it. And then there's going to be this circle thing. And then that's coming down. And then that's coming down. And that's a circle thing. Okay, so if we call this distance R1, and we call this distance R2, and we call this distance L from there to there, and we call this L1 from here to here, then the area of our frustum is going to be the area of the big cone, which is pi R2 times this L1 plus L. Then I'm going to subtract off the area of the top of the cone, which is going to be pi times R1 times L1. Okay. All right, so now this formula we manipulate a little bit, and we get, we now have this formula, but we have to get rid of the L1. So now we have to dump L1 because L1 is not a parameter in our frustum. Okay, so let's see. How do we get rid of L1? Well, we've got some similar triangle stuff we can use here. Like we just look at this and this. We could say that L1 over R1 is the same as L1 plus L over R2. Okay, so if I manipulate this a little bit, R2 times the L1 is equal to R1 times L1 plus L. Now this is just a bunch of busy work, okay? And in our formula,
Are we taking the test?
so this is R1 L1 plus R1 L. That's R2 L1. So L1 times R2 minus R1 equals R1 L. And so in the equation that we had way back up here for the area of our frustum, okay, when we put that up into there, let's see here, leave myself enough room. the area of the frustum is going to, you got a question? So the area of the frustum
I don't see any summation box. People just scan.
is going to be, so instead of, hold on. Let's see here.
For you.
Okay. So if I go back up to this formula here, the top one that's underlined, what I've got is L1 times R2 minus R1. So this area of the frustum is pi, then it's going to be times R2 L1 plus pi R2 L minus pi R1 L1. Okay, so that's going to be pi times the L1, and I'm going to combine this one and this one to get R2 minus R1, and then plus pi R2L. And this is going to be this is going to be pi times this thing is equal to that thing. So that's going to be R1L plus pi R2L, which we can write as pi L R1 plus R2. Okay, now what he does next is he sets R to be the average of these two guys. And so the area of the frustum is going to be 2. Then I have this pi thing, and then here's the R, and then the L. So area, let me see if I can write that nicer, of the frustum is 2 pi R and L. Okay, now remember, L is the length of the side thing. Okay, so now here we go. So with all of that being taken care of, now we can do the calculus stuff. Okay, so we will partition the interval AB into and equal with subintervals, A equaling x0 less than x1. Same old mumbo jumbo we always do, equaling B. Delta x is going to be B minus A over N. And that's the same thing as xi minus xi minus 1. Okay. And as we do this, we're going to find a lot of similarities from what was going on last Thursday. Okay. So let's say that like this is where xi minus 1 is, and let's say this is xi. Okay. And the function, let's say this is the point pi minus 1, and then this is the point pi. Okay, now the function is going to be doing something smooth and through here like that. Okay, but what we're going to do is we're going to approximate that distance with this straight line distance. Okay. So this thing right here, which is the distance from pi minus 1 up to pi, that is the L from the formula. Okay. And the R1 and the R2 are just the f of xi and the f of xi minus 1. Okay. All right. So if we look at the distance, well, let's write down pi minus 1 is xi minus 1 f of xi minus 1. And then pi is xi comma f of xi. Okay, so the distance from here to here, this is just straightforward distance formula. So it's the difference in the x's squared. Okay, well, xi minus 1, that's delta x. Okay, and then this one, you know, I'm not going to reinvent the wheel. This is the same exact thing we did. F of xi, okay, squared. And what I'm going to do here is I'm going to insert the xi minus 1 and the delta x being squared. Okay. And so this slant height thing, which is this pi minus 1 to pi, ends up being the square root of 1 plus f prime of some xi star that's sitting in the middle of those two guys, delta x. Okay. Now this is when on Thursday, if you go back to your notes, the mean value theorem, it's the same thing that we did last time. Okay. All right. So now we need to start talking about everything else. Okay. So we've got our little bit of area, let's call it delta A. Okay. And what it would be, where's that formula again? 2 pi RL. Delta A is going to be 2 pi RL. Okay, so L is the slant height. Okay, so this is going to be 2 pi. Okay, now this R, if you remember, is R1 plus R2 over 2 times this thing that keeps showing up, squared delta x. And if you want, you can say, okay, so this is 2 pi. Now R1, that was all the way back up here at the picture. Okay, so R1 is going to be the f of xi. Okay, so this is going to be f of xi plus f of, xi minus 1 plus f, I messed that up. Let me do that better. This is going to be f of xi minus 1 plus f of xi all over 2 times the square root of 1 plus f prime of xi star squared delta x. And that's a crappy looking triangle. Delta x. All right, now there's a slight little hitch in our giddy up. Okay, we've already used the mean value theorem to get this random point in between the two, xi minus 1 and xi. These guys right here can't be in the Riemann sum. It has to be all that stuff. Okay, but here's what we can say. That if delta x is small, then f of xi minus 1 plus f of xi over 2 is almost going to be the same thing as f of xi star. This is provided the function is continuous. Okay. Now this is me intentionally doing squiggly equal sign. It's almost equal to that. Okay. So our delta A, our little bit of area, is then going to be approximately 2 pi f of xi star. Then it's going to be the square root of 1 plus f prime of xi star squared delta x. And just as we've done several times earlier, what we're going to do is we're going to define. We're not going to find, we're going to declare it to be something. We'll define the surface area. Now in your book, he uses a capital S. I can't do that because you're not going to be able to distinguish between lowercase and capital S. Lowercase s is always reserved for arc length. So we're going to define A to be the limit as n tends to infinity of the sum I equaling 1 to n of all this crap. 2 pi f of xi star, and I got square root of 1 plus f prime xi star squared delta x. And we all recognize that this is the Riemann sum of the following integral. A to b 2 pi f of x square root 1 plus f prime of x squared dx. And this goes in a box and have a parade for it. Okay. Another alternative way of writing this would be the integral from a to b. You know, if y is equal to f of x, you see these formulas quite often. 2 pi y square root of 1 plus dy dx squared dx. Or we could, if we, well, let's hold off on that. Okay, now let's do it on a thing that we know the answer to. So let's say that I took the top half of the circle of radius 1 and I spun it around here. Then I'm going to get a ball, right? The surface area of a ball is going to be 4 pi r squared. The way I remember that is it looks like it's the derivative of the volume, which is 4/3 pi r cubed. Okay, so here's our y equaling the square root of 1 minus x squared. Okay, so for y equaling the square root of 1 minus x squared, 1 plus y prime, that's what's under the radical, is going to be 1 then this is going to be minus 2x over 2 radical 1 minus x squared. So no wait. What's that? Go away. Okay, so y prime is going to be 2, 1 minus x squared, negative 2x. So 1 plus y prime squared is going to be 1 plus x squared over 1 minus x squared. Common denominator it up over 1 minus x squared. And we see that we get 1 over 1 minus x squared. Okay, so our area is going to be the integral from negative 1 to 1, 2 pi radical 1 minus x squared times the square root of 1 over 1 minus x squared dx. And that's easy enough. All that stuff cancels, and I get 2 pi dx. So it's 2 pi x, negative 1 and 1. So that's 2 pi minus negative 2 pi, which is 4 pi, which is exactly what we wanted to get with the radius equal to 1. So that's pretty good evidence that we're on the right track, don't you think? Let you guys catch up for a second. You guys have any questions on that one?
How do you get the bounds in there?
Circle of radius 1. So that's negative 1, and that's 1.
Okay.
Got it?
Professor, isn't the last answer minus 4 pi?
Say that again?
No, the answer isn't. Oh, sorry, I didn't see the. My mistake. Sorry, it's my mistake. I thought it was a multiply.
Oh yeah, it's a.
Okay, plus. So, thank you. Sorry.
Okay. Okay, now. Let's try one. Just from the exercises. Okay. So, example. How about y equals the square root of 1 plus e to the x. And we're going to rotate this about the x-axis. Okay. And we're going to go from 0 to 1. Okay, so when x is, what it's going to be looking like is something like this. So when x is 0, it's going to be a square root of 2. So the problem is it's starting at radical 2, and the square rooting function goes like this. So basically, it's this region right here that we're spinning around and trying to find the area of. Okay, so we'll do the y prime thing again. So y prime is going to be 1 over 2 square roots of 1 plus e to the x times the derivative of the inside, which is e to the x, and 1 plus y prime squared is going to be 1 e to the 2x divided by 4 times 1 plus e to the x. Okay. And so our area ends up being the integral from 0 to 1. Now it's 2 pi times the f of x, which is the 1 plus the e to the x guy. And then it's the square root of this 1 plus e to the 2x divided by 4 times 1 plus e to the x. Okay. Give you a second on that one. All right, so let's see here. Start trying to clean this up. 0 to 1, 2 pi, 1 plus e to the x. Okay, now this is going to be times the square root of, let's see, 4 plus 4 e to the x plus e to the 2x divided by 4 times plus e to the x. And what we see here is that the 4 is going to cancel with that 2 because it's under the square root sign. These two guys are going to cancel. And so what we're left with is the square root of e to the 2x plus 4 e to the x plus 4. Okay. Now here comes the next. Oh, come on. Give me a break. So now we're all supposed to recognize that that is the perfect square e to the x plus 2 being squared. E to the 2x plus 4 e to the x plus 4. And since everything is positive in there, square root of the squared, it's just going to give me that. And it's e to the x plus 2 dx. So that's going to be e to the x plus 2x, 0 and 1. So that's going to be e plus 2 minus 1 plus 0. So that's going to be e plus 1. Is this the kind of problem that I would put on an exam that had that answer?
No.
Hell yeah. Look how easy it is. E plus 1.
Yeah,
these
that
answers-
answer is easy. Getting there was not.
Right. Now, the unfortunate thing with arc length and the surface area is the Bobby rules don't apply anymore. For me to arrange it so the surface area is exactly 1, it just takes way too long. So, anyways, there's our.
Bobby, I have a question.
Yep.
In this step from e to the 2x, how it's become 4 plus 4ex plus e to the power of 2x? Like how is it changed?
Okay, so fuck. What was this?
1 square root.
Yeah.
Okay.
So what I did is I common denominated this.
Okay. So I multiplied it.
That's me doing a common denominator.
Okay. I
Okay.
see. Yeah.
There's a lot of, this is what I've been, like you guys that have been with me since pre-calc, I've been telling you this. The algebra is what is going to get you, you know. Okay, now, some more stuff here. If we've got that x is like a function of y, like that, and it's positive for y between c and d, if we revolve about the y-axis, so meaning like this, like here's c, here's d, and I have a perfectly good y is a function, x is a function of y, and so it's going to rotate around this. So all of the letters just get relabeled. So you're going to go from c to d, 2 pi g of y, then the square root of the 1 plus g prime of y squared dy. And sometimes we see this written like this: c to d, 2 pi x square root 1 plus dx dy quantity squared dy. Okay. Okay, now in the book, he starts writing down these alternative formulas. Okay, and so in the book, he says, okay, well, the area, if I'm going to be revolving around the x-axis, that the area is this integral from a to b, and it's 2 pi, and then he says y square root 1 plus dy dx squared dx. And then he says if x is g of y, blah, 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 we get this, okay? So when, wait a minute. I have edition 7 out here. I want to get the edition that I like. So, okay. He writes something down that's kind of confusing in older versions of the book. So I'm back in like the 5th edition now. Okay. I know some of you use some of them that are that old. Okay, so in the book, he writes down this equation like this one right here. Okay. And then he says that if, like I said, you know, if x is a function of y, then the area is going to be a to b 2 pi y square root of 1 plus dx dy squared dy. y. Okay, now notice back up here, I said if we've got this thing revolving around the y-axis, this is the formula. Okay, now look at that one and look at this one. You see the difference? Right there. Okay, so I always thought that was a misprint. Well, I mean, the first time I saw it, I thought that was a misprint. But then when I started preparing a lecture, and this was, you know, many years ago, my calculus textbooks did not cover surface area like this. So the first time I ever saw this stuff was when I was teaching it at math at UC Irvine. They used this book, okay, or at least Stewart. And so I thought that this was a misprint, but it's not, okay? So what this is saying here is this. So recall that the ds differential element of arc length could be expressed like this. It could also be expressed like this. And do you remember my reasoning? No matter how you look at it, the length is the length is the length. It's not going to change. Okay? So if we're revolving around the x-axis, the area is going to be from A to B, and then it's going to be 2 pi y ds. Now ds could be, whoops, dx, dy. ds could be either one of these things, okay? And so if you are revolving around the x-axis, you're always going to have a y here, but you can do a dx integral or a dy integral. Okay? Then if you revolve around the y-axis, revolve about the y-axis, well, once again, our area is now going to be this c to d thing. The 2 pi x is the thing that stays fixed. And now you have the ds, where you can choose either one of these two forms. Okay. So let me do a problem that'll work on. Okay, so I'm going to do number 1 in the book. Okay. So number 1, at least in the old textbook. So example, I'm going to have y equals the natural log of x from 1 to 3, and I'm going to go about the x-axis. Okay. So the area is going to be the integral from 1 to 3 of 2 pi y ds. Okay, now if we do a dx integral, then number 1, we'll do a dx integral. Okay, so now the area, the integral from 1 up to 3, 2 pi, then it's going to be times the natural log of x, 2 pi y, and then the square root of 1 plus that derivative squared dx. Okay. All right, now this is where we're stopping because it says set up but don't evaluate. Okay, so this obviously we're going to have to approximate this. But what I'm trying to illustrate is this. If I wanted to do a dy integral, according to the book, if I want to revolve around the x-axis for a dy integral, the area is still going to be this integral. Well, I have to figure out x is now e to the y. So when x is 1, y is 0. So x is 1, y is 0. When x is 3, y is the natural log of 3. Okay, well, anyways, so if I want to do a dy integral, I'm going to have to go from 0 to the natural log of 3, 2 pi. Now, the y just stays there, okay? And then it's you don't put it back in. 1 plus the derivative squared, and then dy. Okay. I have one that I can do both different ways. So let me get it in my notes. It's either the cube root or x to the 2/3. So right. So let's see, where left is it x to the 2/3 or x to the 1/3? That's 3. There we go. All right. So, yeah, cube root. Okay. So for our next example, we'll look at this guy. Okay, now this one we actually will take to completion. All right. So I've got y equals the cube root of x, 1 less than or equal to y less than or equal to 2. And I want to go about the y-axis. Okay. All right. So if I want to do a dy integral, we would have to then say x is equal to y cubed. And when y is 1, x is also 1. But when y is 2, the x is 8. Okay, so that means that the x's are going to be running between 1 and 8. Okay. All right, so our x prime is going to be 3y squared. And so I'm going to have 1 plus x prime squared, 1 plus 9y squared. Okay. All right, so our area now is going to be a dy integral. So this is y goes from 1 to 8, 1 to 8, 2 pi. Okay, now since we're going around the y-axis, the x goes right there. Okay, and then it's going to be the square root of the 1 plus, this is 9y to the 4th, by the way, 1 plus 9y y to the fourth, then dy. And the x, we have to get rid of it. It's 3y squared. And then no, the x is y cubed, not the derivative. The x is the y cubed, 1 plus 9y to the fourth. Okay, so you guys see how to do this integral? Real easy. Oops. When I asked that question, Siri thought I was.
Hey, Ty had a question. He said, is it 1/8 or 1/2?
What am I, wait. Yeah, it's supposed to be 1 to 2.
Okay, so it'd be.
I'm going to do the dx integral next. So it's still 1 to 2.
Oh, okay.
Okay. Okay, now this one is kind of easy, you know. This guy, so the du is going to be 36 y cubed dy. Okay, so I'm going to have 2 pi over 36 integral when y is 1, u is 10. When y is 2, 16 times 9 is 144, 145. And then it's the square root of u du, which is pi over 18, 3/2 over 3/2. Then it's u to the 3/2, 10, and 145. So I'm going to get pi over 27 and 145 radical 145. This is how your book writes these things down. Minus 10 radical 10. Like, even I started doing it, but it's 145 to the 3/2 power minus 10 to the 3/2 power. Okay, so now let's do it with a dx integral. Okay.
Hey, real quick before you move on, Nam had a question. How do we get 60 and 145?
I don't see 60, but 145.
I think maybe they mean 10. I think they must mean 145 and 10.
10.
Yeah, probably.
Okay, so remember that these bounds are for y, right? These bounds right here. But now that we're doing the u substitution, when y equals 1, the u equals 10. And when y equals 2, the u is 145. 9 times 16 is 144. Add 1, you get 145. So now the bounds change to that kind of an integral. Okay? All right, so now let's try the dx integral. Okay, we're still going around the y-axis. Okay, so our y is equal to this cube root of x guy. Okay, which will be x to the 1/3. And if we want a dx integral, we have to go up here and look at the y is going between 1 and 2, but the x's are going to run between 1 and 8. Okay, so our area is going to be from 1 to 8, 2 pi x, and then the ds piece. And we want to do a dx integral. So it's going to be 1 to 8, 2 pi x, square root of 1 plus dy dx squared dx. Okay, so y prime is equal to 1/3 x to the negative 2/3. So 1 plus y prime squared is going to be 1 plus 1 over 9x to the 4/3 power. Okay, so the area is going to be from 1 to 8, 2 pi x. Now the x just stays there as its own letter, okay? When I do this in the normal lecture class, I actually go through the frustums as to why this is working with a dy and a dx. But I think that now, because of our discussion of ds, maybe I don't need to do that anymore. So sometimes you'll be doing one of these problems and you will start down with a dy integral and you think it's too hard. And so you might think, okay, I'll switch to a dx integral. That's the game you can play with these things. Okay, so now let's see here. What would Bobby do? Well, he would probably common denominator the fraction to get 9x to the 4/3 plus 1 over 9x to the 4/3. And then he would probably undo the square root in the denominator x to the 2/3. Write that better. Divided by the square root of 9x to the 4/3, which is going to be 3x to the 2/3. And so now I'm going to have 2 pi over 3 integral from 1 to 8 x to the 1/3 square root of 9x to the 4/3 plus 1 dx. Now do you see it? Straight U substitution. If u is equal to 9x to the 4/3 power plus 1, then du is going to be 36 over 3 x to the 1/3 dx, which is 12x to the 1/3 dx. Okay, so now I'm going to have to go 2 pi, and now I'm over 3. Now I got to do the 12. Okay, and then the bounds of integration, when x is 1, u is 10. When x is 8, cube root of 8 is 2. 2 to the 4th is 16. I still get this 145 thing, square root of u du. And this simplifies to pi over 18 times the integral 1 from 10 to 145 square root of u du. And if you notice back in the other problem, we ended up with pi over 27. And where the hell did I get 27? This is supposed to be 18. Yeah,
I think a lot of people were like me, just trying to copy as fast as possible.
Oh.
Oh, actually, what about the pi over 18 times 2/3? So wouldn't that give you the?
No, we got it right. It's just that for some reason, I thought it was 27. 2 goes into 30. See here? Oh, fuck.
I think you might have had it right with 27.
No, yeah. Okay, then where's my 18 then?
Give me 1 second, man. I think you got this right though. 2 pi divided 18 times 3, 54 divided by 2. Yep, you got it right.
It is the 27?
Yeah, it was pi over 27 because scroll up to where it was just a little bit.
Yeah, I agree. So let's look at where I made a mistake here then, because why am I getting an 18? Okay, so let's go. Here I am setting it up.
Okay.
Okay, so it's a dx integral. So y prime 1/3 x negative 2/3. Square it. That's right. That's right. That's right. 2 pi x. Okay. And then
Could be where you do that with the 3x 2/3. I mean, I haven't got a chance to do the math, so that's the thing that I saw that was done really quickly.
so the 3 comes outside.
Okay.
This is x to the first minus x to the, the x to the first over x to the, so that's correct. So u is here. Okay. And it's, okay, so u is 9x to the 4/3. So du is 36 over 3, x to the 1/3. That's a 12. So where am I going wrong? There's the 2 pi over 3 over 12. 2 pi over 3 and a 12. No, it's 18. This is 18 up here.
Yeah.
Yeah, it is. It's 18.
So we square 1 to the 8. Oh, there you go.
But I do have a question is like right above that, you have pi times 2, and then 18 times 3, which is 54, and you have 2 pi over 54, which is pi over 27.
Well, unfortunately, I erased what was in front of this integral. I think it's 2 pi over 36.
That was correct, yeah.
Okay. And
Which
so
I
now
raised
that's
right here.
pi over 18 times 2/3.
Yeah, that's 2 pi over 54, which is pi over 27.
Yeah, so it's 27 is the right one.
Yeah, so I don't think it's pi over 18. I think it's pi over 27, like you previously had.
Okay.
And it's like all the math I can do though, so I couldn't tell you what else would be wrong.
So go back. No, that's still pi over 18.
Correct.
It's this additional 3 now changes this guy, because now 2 goes into that, so that it's 27.
Yeah, pi over 27. Yeah.
Yeah.
You got it right. You had it right the first time.
Yeah. That happens, this happens every now and then. Okay.
You just do it really quick in your head. That's the problem. Like it's done so fast. A lot of us don't know what's going on.
And so once again, I did another brain fart here. So this is going to be, well, it's the same exact integral is the point I was trying to make. Okay, so we can forget all this crap. This is the same exact integral that we got. This one right here is right there.
So I don't totally understand this, but Ty said that I think x in the second one, and maybe that makes sense to you, should be x to the 1/3. That's what he's saying. In the second one, not sure.
Yeah, I've got it, x to the 1/3.
Okay.
If that's what he was
Right here. Yeah.
asking about. All righty. So as you can see, these problems are kind of interesting. Okay, now that we've done some improper integrals, let's do Gabriel's horn. Okay, so we're going to have y equals 1/x, and we're going to allow x to go from 1 to infinity. We're going to revolve about the x-axis. Okay, so the volume of this, if you guys remember how to do that, it's going to be the integral from 1 to infinity, and then it's pi, and then it was the function squared using the disk method, dx like that. Okay, so that's going to be pi times the integral from 1 to infinity x to the -2 dx, which is going to be pi over x squared evaluated at 1 and infinity. And so we get pi minus pi over infinity, which is 0. Okay. If we did the area, it's going to be from 1 to infinity. Now it's going to be 2 pi, then y, 1/x, and then the square root of 1 plus that derivative, which is going to be 1/x squared dx. Okay. All right, now we can play with this guy a little bit to see what, if anything, is going to come from it. 2 pi times 1/x square root of, this is going to be x squared plus 1/x squared. So that's me common denominatoring it up. And then it's going to be from 1 to infinity, and then it's 2 pi, and then it's going to be square root of x squared plus 1 divided by x squared dx. Okay, now unfortunately, if we, well, here, let's just play with it a second. Okay, so if we do a rationalizing substitution like this is about the only thing that is might work. Okay, then u squared is going to be x squared plus 1. So that means x squared is u squared minus 1. And so that would be the square root of u divided by u squared minus 1. And then here's the problem. 2u du equals 2x dx. Okay, or u du equals x dx. Now we don't have x. We would have to solve for it from here. But because it's x squared, it's going to be a problem. Okay. However, do we all recognize that the integral from 1 to infinity of 2 pi times the square root of x squared plus 1 divided by x squared dx? Do we all see that this is smaller than the integral from 1 to infinity of 2 pi square root of x squared over x squared dx. See, this guy, oops, I have that the wrong way.
Isn't
Right.
yeah.
Yeah. So this guy is smaller than that guy. So hold on, back to the drawing board here. Okay.
Oh, you have to just flip this one.
So this thing, come on, raise, is bigger than this integral, 1 to infinity, 2 pi, square root of x squared over x squared dx. And then if we just do this thing, it would be 2 pi times the integral from 1 to infinity of x over x squared dx. Everything's positive. This is leading to 2 pi times the integral from 1 to infinity of 1 over x dx. Now, this is one of the first improper integrals that we did. It's 2 pi, natural log of x, evaluated at 1 and infinity. This is plus infinity. It diverges. Okay? So the integral that we have is larger than this one, and this one is infinity. So that means this is infinity. Okay, so this is the interesting feature about this so-called Gabriel's horn. This Gabriel's horn, it has a finite amount of volume, as we found, but an infinite amount of surface area. Okay, so that's something for you to, you know, contemplate while you're contemplating your navel. Okay, so infinitely long surface area, infinite amount of surface area is required to contain a finite amount of volume. So to me, I think that's, you know, kind of odd.
I find it kind of cool.
Yeah. There's some other weird ones. There's in order to make logic and stuff make logical sense and whatever, there has to be a set of axioms. We have encountered one of the axioms in Math 180, which was the Completeness Axiom, which said that every bounded subset of the real line has a least upper bound. And so that was an axiom, meaning we take it that it's true and it can't be changed. Okay. There's another axiom called the Axiom of Choice. Now this seems kind of kind of dumb, but if you're given a bunch of sets, you can take one element out of every one of those sets and make a new set. That's called the Axiom of Choice. Okay, and from that comes the Banner-Tarski paradox. I could take a baseball, or, you know, any other solid ball, like a golf ball, and in a finite number of steps, I can cut this up and reassemble it into two balls of the exact same weight, volume, area. Okay, so what does that contradict? Contradicts the laws of common sense, right? But, you know, conservation of energy, all that. But these are all kind of these little consequence things that you get. Okay, so as far as the exercises to do, I would just do a lot of them. You know, I just did number 13 both ways. Any of these problems, if there's a way to do them, you know, both ways, like I'm seeing number 7 could be done with a dy integral and a dx integral, like this one. I don't know if number 7 in your book, but it's just y equals the square root of x about the x-axis between 4 and 9. So, do a dx and do a dy and see what happens. Okay, so for your test tomorrow, let's undo this stuff here. I haven't made it yet. Whoops, there we go. So I haven't made the test yet, but it's going to be like 10 integrals,
Okay.
and I'll put some easy ones on there that, use substitution will do the trick. Integration by parts, you have to do one time, partial fraction decomposition. Okay, now that's the one that's going to look weird. So I have in the function that I want you to integrate, it's all jacked up. Okay, but the reason it's all jacked up is because when you do the a, b, and the cx plus b and all that stuff, all those numbers become ones and zeros and whatever's convenient in the answer. So, like, for example, if I want the answer to be tan inverse of x minus the natural log of x plus 1 over x, those three pieces, I will take the derivative of all of that stuff and then put it all in a common fraction, and let me get to my thing. So as far as the trapezoid and Simpson's rule, there's going to be one where I'm just going to say set it up. Okay, so let me share the screen again and show you what I mean. So share the screen. It's so muggy in my house. There's one note. Okay. So, like, I might say, approximate, this guy by using the trapezoid rule for, n equals, I don't know, let's say 4. Okay, so the trapezoid rule, we're going to have a delta x in 4 intervals. Okay, so the delta x is going to be 1/4. Trapezoid rule is delta x over 2, and then it's y1 plus 2y2 plus 2y3 plus y4. And so what I would want to see is you write down 1/8 times 1/1 plus 2 over the x, which is going to be 5/4 plus 2 divided by 1.5, 6/4, 2 divided by the 7/4, plus 1 divided by the 8/4. I would just want to see that. Now the function will probably be something like this, 1 plus x cubed or something like that. And then there will be one question where I'm asking you to figure out how big n needs to be. Okay. Now this is going to be kind of an interesting experiment because if anybody misses that question, I mean, you can look up in the book. It's not like I'm watching you, Maybe I won't put one of those on there. Maybe instead I'll just put another interval. I don't know, whatever. Okay, let's see here. So tomorrow we'll just try this and we'll see how this goes. Do I have any practice tests? Yeah, just get in the book and start integrating. There's no
Hey,
trick. There's no word
Professor.
problems, nothing. It's just intervals.
Professor?
Yep.
So real quick, I'm sorry, but how'd you get the 5/4, 6/4, and 7/4?
I partitioned the interval 1 to 2 up into 4 equal width subintervals.
Uh-huh.
Okay, so that means the width is going to be 1/4.
Okay.
So the first guy is value is the x is 4/4, and then 5/4, 6/4, 7/4, and then 8/4.
Okay, so you partitioned it as 1/4 parts, and then that's how you started writing. Okay, got it. Thank you.
Yeah. Okay. Let's see. News today, we have a new interim vice president of instruction. Don't know what that means to any of you, but she came from sort of like a bounce around person. She's been everywhere. Not that it means anything.
I think the other thing that's funny is that we Kanye West running for presidency.
I don't think he can. Like, I know it sounds weird, but I think it's too late.
He can, but he has to do it as a what's it called?
Independent?
Independent.
Yeah, I mean, it's essentially.
No, don't you have to file paperwork saying that I'm gonna be?
So he can file paperwork. The only problem is that he won't be able to be on what's it called, on the ballot. For a few states like Texas and I believe.
For you guys that are a little bit young, there's this crazy guy named Joe Walsh, and he played guitar for this band called the Eagles. Talking to you youngsters. Okay, so back when Bush was running in 1988, he was all over MTV. Joe Walsh came out and he said, "I'm running for vice president." Now you can't run for vice president, but yeah, that's what I'm running for vice president. So there you go.
Yeah, I mean, I thought it was interesting. I mean, if he was doing it for 2024, I would say okay, but this late, like, I mean, I don't know all the rules, but from what I've gathered, like, it's pretty much impossible for him to.
I'm getting the impression that Trump doesn't want this job anymore.
Yeah. Well,
he kind of just, in the interview with the mask, he said, I guess so. Okay, fine, put on a mask. And then he did his bubble thing today that was just so stupid.
I mean, though, would he be Kanye West? Would he run as the Republican? I mean, we've never had in my
independent
place.
He would be independent.
But I'm saying though, like, that's essentially losing. So once he realizes that, he'll probably wait till 2024. There's an independent.
You guys really think Kanye West is going to go through with this?
I mean, there's crazier things that have happened.
Here's who should be president: Bob Costas.
Bob Costas. I don't know who that is.
He's the guy that calls the Olympics, and they want to tap him. He's like probably the most well-known sportscaster after Vin Scully.
I like Andrew Yang. Did any of you guys follow what he was talking about in his platform? Dude, he was a really, really bright and brilliant person, and his kind of full platform was setting up a universal basic income, not just like give people money, but because automation is going to get rid of so many jobs that if we don't start, because he was from the tech sector, and he's like, so if we don't start dealing with this right now, then when these jobs are gone, there's going to be no way to take care of them. So yeah, I mean, like, UBI, it's a weird thing to even consider, but I just thought he was like a bright guy, because I'm still amazed that they allow people to drive cars, like with how many people die every year. I think it was 30 or 40,000 people die needlessly in car accidents, and we have automated vehicles that could easily probably limit that to 1,000. Like, and after this year and seeing how people react to potential death in, from anything in the United States, you would imagine that they would rip cars off that road like immediately, like everything else, they would block it up. But yeah, anyways, it's interesting. I mean, automation is
we had a car accident last night, so everybody needs to quarantine from the car.
I mean, I don't mean to make a joke out of it, but I mean, I forgot the actual number, but it's really, really high. And
so this one former NFL guy who played at USC, he was on the Mason and Ireland show today. Tony Baselli, he's an old lineman, and he got COVID, and he had a hard time. Like, he was talking about it on the show today, saying, yeah, I was one of the people that it hit hard, and there was a couple of days in the hospital where it was just bad. And then you got my neighbor Russ, who, I mean, the guy's in the worst shape. He does drugs. He has to sleep with a mask on because he can't. Yeah. And he got COVID, and he's like, yeah, I'm fine.
It's totally random, man. I talked to somebody, a 90-year-old grandma who got it and was okay, and talked to somebody else who's 45 and somehow dies from the thing, or 30, which is very neat.
My father-in-law works for Maximo.
Okay.
One of his employees on not his floor, thank God, not his floor, divisional floor, got it, and then was talking to another person and just nonchalant tell him, oh yeah, so my father has it. And then he called HR, the guy that was being talked to called HR on the guy that was talking to him. I said, hey, I just got this guy that his family member has it, and now he was talking to me at work today. So it's like, you guys do screenings once a week, before you guys get into the office.
Yeah. It's an interesting thing, man. It's definitely one of those things where, like, I mean, I've not tested for this thing, but if I was tested and I found out I had it, I just wouldn't tell anyone, man. Like, I wouldn't try to stay out of people's business, but like, it's so bad that, you can't go to work and you can't do anything else. And
you get tested and it comes back positive. How do you know it's a real test?
I mean, you don't, but what I'm saying is, like, it's
these
just
shit tests. These are things that they're manufacturing by the millions. That they're not like being careful. We're getting a bunch of garbage that.
Well, they should do the test that Eduardo took. The first one that you said was pretty accurate.
The blood test to see if you have the antibody.
Yeah, my guess is, man, like almost everything else in medicine, it's just they don't want to spend the money. Like, I had a buddy, we were talking about, I had a friend who had like a rare heart condition that he could have found out about. I was talking to my buddy who's a doctor. I'm like, hey, why don't they offer MRIs or like CAT scans, any of that type of stuff? Why is that so difficult for the normal person to get? He's like, well, we can't waste money on people. They're just not worth it. And that was what my buddy said with ICU tests as well. Like, for this stuff, I was like, hey, man, like, I'm going to lose my job again here in a few days. And he's like, well, if we add 10 more beds to our hospital, it costs us more money than those people are worth. So we have to keep the ICU beds down to 40. That's where we make the most profit. So it's like, I mean, at that point, it makes me kind of like not really care when the hospitals say they're overrun, when it's like, oh, you could add beds, but you don't want to because you guys won't make as much money. Like, that's administrative and such. But I definitely.
I had a conversation with my father-in-law the other day because he does the engineering through the medical field, and my brother-in-law does the same thing, because we were all sitting together. Like, we have these camps that we know we don't have, like the Manzanillo.
Okay.
We have the other one that's like in San Diego. These are abandoned places that we can turn into hospice locations for people that have conditions and then have it run through the military, right? Yeah. You go in, you check out, you tested positive, you're sitting there, we're going to monitor you, we're going to test you. Once you're green, you're out.
Yeah, well, they brought those boats over and they never used them. So, I mean, the problem is, man, like, I don't know if there's not enough people getting the disease or that they're all going to one hospital, but like, there are many hospitals that are not overwhelmed at all. But for some odd reason, there are like certain hospitals. I don't know, like, hey, maybe these are the only hospitals that take this insurance. I have no clue what the reasoning is. but certain hospitals are crazy overwhelmed from what I've read right now. And so we have to close down tons of stuff because of, in this county, 5 of the 10 hospitals are overwhelmed. So for me, that seems like a simple logistic thing when it's like, these are not heart attack patients, like we could probably transport them safely from one hospital 3 miles away or 4 miles away to another one. And probably wouldn't be that big of a risk. But that's, like I said.
Both Mission Hospital both Mission Hospitals, the one that's on Laguna and the one that's in Mission Viejo, are completely like they're out. They're like they can't. They're almost putting people outside.
Okay, yeah, like I haven't checked today, but like Hoag Hospital was pretty empty. So like they could put people at the one in Newport. Like it's just, for me, there's just so many like oversights. It's kind of like, and it was nice when they made it. It was kind of like when they created the new Unemployment Act, like all this stuff is like, it was like, hey, we're not prepared for this thing. Do this thing immediately and don't think about like the cost, like how it works, any of that stuff. Because like in states like Kentucky, where like their average monthly wage is like $1,200, they were getting $600 a week on top of whatever to stay home for unemployment. So it was like a lot of people don't want to ever go back to work there, understandably so. Here it's still nice, but it's not like as high as those other states where it's like cost of living is $600-800 for your rent, whatever. You rent a house. But yeah, man, I just think the thing that bothers me, I think more than anything, is I can kind of understand rash decisions in March. I don't understand rash decisions in July. Those are the things that, like, we've had 3 or 4 months to think about things. Time to like start, putting a team of people in a room and using their brains and stuff. And what I've noted, the only thing I've noticed is that not like people like us talking, but like people in power, just all they want to do is place blame on another person.
Yeah, they don't know who to shoot in the foot.
Just
That's the problem.
step up somewhere. If the president can't do it or whoever else can't, somebody needs to. Because
he's known to hire the right people, right?
Yeah, it's like family members or whatever.
He's that right person in his staff.
I don't know. We'll find out what happens here. I think honestly, this month and next month are going to be real. The whole year is going to be interesting. But this month, these months,
the whole year's gone. It's done.
But there's going to be a lot of stuff that if they have 2 options now at this point because they keep closing stuff down. It's kind of what they have, even if they would have kept stuff open. Pump $4 trillion more into the economy, which you're already looking at hyperinflation at some point, and continue to keep everything afloat for 6 months, 9 months, whatever. Or cut everybody off, which is 20% unemployment right now, and see what happens. So we'll find out at the end of the month, but it's we're at that point again. And like I've heard about a lot of job growth, but I've been looking, and it's just as, in my opinion, it's a little bit worse than it was before March. And people would say, oh, it was great before March. I've been looking for jobs, like career jobs, for the past 3 or 4 years. And most of them either offer $26,000 a year or are impossible to get because you're going against, 2,000 or 3,000 people who are qualified. So, or younger. That's a big thing too. If you didn't go to school and get out at 21 and take the lowest paying job you could, you don't have the experience they need. So it's interesting, man. I don't really see a good solution. Glad that we're talking about stuff.
I have a few friends that when they graduated at 21, some of them got internships while they were still studying.
That's smart. That's what
and barely passed their classes to graduate because of the internship. But because of the experience through the internship, they immediately got hired after like 2 years.
I'm just too old and too dumb, man. Like I was in school at 24. I wanted to get out quick. I had a 4.0. I thought, hey, I've ran a company before. I've done a bunch of other stuff. This should be cake. It's a small company, but I thought, okay, this should be easy. I was looking for a job that paid like $40,000 a year so you can live, not comfortably, but live. But no, the only things I got offered were like $28,000. And then I applied to about 250 entry-level positions from about 2014 to about 2015. But yeah, man, I mean, it's interesting.
So
world.
my friend Eric, it took him 6 years to get out of Cal Poly, and degree in finance, and he's the one that eventually did investment banking. And the deal that 24-hour fitness got put together,
yeah,
it was a group of investors that they bought up all the LA Fitnesses, Bally's, and they created 24-hour fitness. Well, Eric was on the team for that one deal. For that one deal, by the way, he got $285,000.
Wow.
And his boss, like several million. So anyways, Eric didn't just land that job out of college. I remember I was in grad school, living kind of close to where I am now, just down the street in these apartments across from the Santa Ana Country Club. And, Eric was working the front desk at the one of those hotels near the airport,
Okay.
the 11 to 7 guy.
Oh, wow. That's correct.
Yeah, he couldn't. He was interviewing, driving up to LA and this and that and the other. And a lot of times you got to like think about, what degree you're going after. If you're going after an art history degree, and what kind of jobs I mean,
I understand. I made some poor decisions.
then as opposed to if you have a degree, I'm not just trying to, toot my own horn here, but a degree in math opens up doors. It's because it's a scare factor. It's like, oh, you have, that means you can figure anything out. Okay. As opposed to poor Eric, who, he had his degree in finance, took him a year, and he got lucky with that job. He was at a party at the frat house some Saturday night, and this chick that worked for Myers was at the party, and Eric starts talking to her, and she said, well, maybe, you should, come up to Pasadena, and, I'll give you my boss's number. They might be hiring people. It was just a fluke meeting at a party, like a frat party. So if you're getting discouraged, just try to, I mean, with me, I graduated and went straight to grad school, and the job that I got, the consulting job, again, because of a math degree, and I hated it, but to be full-time at a community college is hard. And so this didn't just happen, it took me like 3 years of being an adjunct and learning this and that and the other. So it does take some time, if it's not happening immediately, it's okay.
I'm a little bit concerned, though, that like those things that you just mentioned, at least for the foreseeable future, the idea of like meeting in person or going to offices or seeing employers already is kind of not likely. And then what's happening now that I see as being kind of a little bit more troublesome, and I don't mean to be the negative dude every time, but is the fact that like we are allowing a lot of people back into the workforce that are really, really, really experienced. Like I think I told you guys this time, my sister's boyfriend works for United Healthcare. They're a huge healthcare company. And they laid off 20% of their staff 2 weeks ago. And there's a lot more places that I know of that are going to do that. So, I mean, the competition is going to be literally insane. So
Hey, wait, hold on. Hold that thought. Before the next person leaves, I'm seeing people leaving the room.
Oh yeah.
I had this idea this morning. Maybe a few of you can make some money off of this. So my Math 30 class, they seem really like into it. Like they ask questions, they're engaged. And I was thinking, man, like this one girl, she needs a note taker because of DSPS. So that got me thinking, like, how many of these people need tutors? And so I can ask the class, like, hey, do you guys need a tutor? And then you could email me your guys' phone numbers if you want to be, if you would want to do that. This is Math 30, we're talking about, what's the slope of the line. Okay. And you could set up like a Zoom conference with them, and they can Venmo you $25 for the hour or something like that. So, I'm in week 3 of 6, so it'd be this week and then 3 more weeks. So, if any of you are interested, let me know. I'll ask my Math 30 class tomorrow if they would want that, and I'm sure a lot of them will say yeah. Okay, so back to what you were saying.
Oh yeah, no, that's all I was getting at. Is it's going to be like an interesting workforce. Like I said, I'm not super concerned. I probably should be, because that's what I'm talking about, is like all this stuff happening at once. But the way I look at it is this way: if people don't realize the severity of what's going on in the economic sector, I'm not saying it's the same as health, but see that there is a giant severity going on there, and at some point it will come to them. Like, it may not be today, it may not be tomorrow, but a bunch of buddies who work for a PBS show called Road Trip Nation.
Yeah. all
of its funding from a private corporation that does banking in the Midwest. But if you only have X amount of small and medium-sized businesses, which are all of the businesses that have essentially been going out of business during this, because they didn't qualify for the $2.5 trillion that the government bailed out, then you're looking at I think they say that small to medium-sized businesses employ 80% of the people in the U.S. Some insane statistic like that.
Well, you were talking about inflation earlier.
Yeah, hyper.
And so obviously, to tell you the truth, other than the inconvenience of not being able to go to the gym, this has worked out perfectly for me.
Yeah, I know. It's good.
You guys know, some of you know how bad my back problems are, right?
Yeah.
And so in that second class, which would be us tonight over there, my back would be screaming, and I don't take ibuprofen anymore, and so, but anyways, and then because the economy has gone south, enrollment goes way up.
Yeah.
And so now, both my classes went large. I'm getting paid more on top of everything else.
Yeah.
That being said, I do think that if they don't knock this shit off, this inflation stuff is going to start happening. And so I'm trying to, like, okay, we need this, and this. Like, we need another car. Maybe it's time to buy it now, as opposed to waiting till Labor Day, when who knows.
So here's where I recommend you do, because if you're gonna buy a car, you should totally do it right now. The APR is non-existent. They have loan forgiveness. I think they have 0 something down for a certain number of years. And like you said, with the way you haggle, and you know how to haggle, you basically lower the price of the actual car, not after.
Yeah, my wife, she's been driving. We have 4 kids, on purpose. So, we've been driving. She drives this big ass, Ford Expedition, and now we kind of don't need it anymore.
Yeah,
we like to have it, So what we're going to do is have that as the car for the kids.
Yeah,
and then get her like an Audi or something more reasonable to drive around, and then I'm not getting rid of my Raptor anytime soon, tell you that much. But I just had it leveled too. Got a leveling kit put in, so now it's kind of freaky going into the gym, because in Triangle Square you got to go down into the parking structure. And my friend, before I did the lift or the leveling kit, he goes, "Man, I was watching you drive in. You just clear by this much." And I'm like, and I thought about it the next time I went in. I'm like, oh shit. So
slow down.
I had my roof open, and I've got my hand out. I'm trying to feel. Probably could have broken my fingers if I.
Do you just barely clear without scraping?
Yeah, it's like and it's a little over an inch.
Oh man, but yeah,
I don't drive fast in there because I bounce, and then
I think if you're doing good right now, it is a good time. I'd be cautious, but leaving your money in the bank is not going to help anyone, because I don't know if you guys follow this, but in Japan they went to a negative interest rate, which means they charge you a small fee to keep your money in the banks.
Yeah.
So honestly, I could see that happening here in 6 months to a year. Could potentially be 2, but what?
But if we get back to like when my dad bought the house in Vista that I basically grew up in,
Yeah,
the interest rates back in those days were like 17%.
yeah,
I mean, like I just refied our house at 3%. I don't qualify for that bottom feeder one because that's only for a conforming loan.
yeah.
So,
Like buddies who just did that refinance as well. For those-
but and I totally remember the gas. You guys weren't born yet. When there was the gas shortages, this was all under Carter.
Mhm.
I mean, the guy had just a rough 4 years. I mean, he had about as rough of a 4 years as Trump seems to be having. It's just that Jimmy Carter's just a nice guy, you know. Trump's just kind of a whatever.
Yeah, at this point we can say he.
But I mean, I totally remember it. I remember my parents talking about this, that, and the other, you know, eggs going up to, you know,
$2 or something.
$6 a dozen. And yeah, so it's like that kind of stuff.
I hope I'm wrong, but you would imagine, I think we were at $16 trillion of debt before this year for the US. I would imagine it would be about 25 by the end of the year, with the second act passing. You would imagine at some point, like my dad's a big negative guy, so I'll hear all this stuff from him, and I always tell him, I'm like, hey, I mean, this stuff can last as long as people believe in it, as long as they let us, because it's essentially we're playing with monopoly money. It has no value at all. It's just paper or numbers if you're using credit cards. So it is feasible though to imagine, like, regardless of what they choose, some at least minor consequences. Even for those people who are still able to hold a job, I could at least imagine bread or things like that going up $1, just a reasonable rate, because, you know, there was, I mean, a lot of people I know walked out of this with a lot more money than they previously had, even working people, just due to them having large family sizes and stuff. And I mean, there can't be no consequences for getting $16,000 in addition to your money you make in 1 year, besides just a basic tax thing. So
we didn't get any of that. We didn't qualify.
Oh, dude, there's so much money floating around right now. Like, I didn't even go
Well,
out.
we make too much money. This is the only thing that
There's
I'll
no money
say.
for you, dude. There's money for everyone right now. It's crazy.
I just, you know, according to Obama's definition, my wife and I are 1%ers.
Yeah, I know.
Now, we live paycheck to
Yeah.
paycheck, you know, because we live in Orange County, and, you know, and so this is the only reason I ever want a Republican to be, because the liberals think I'm rich,
Yeah.
you know, and I'm not,
I
so.
I do find it one of the things that I find, because, you know, I have buddies, I don't even know where I fall anymore, but I do have buddies on both sides, and my buddies who are extremely liberal, they want a bigger tax, but then we'll talk about it more, and I'm like, wait, you want a bigger tax on a bunch of people who are barely making it, the 200,000s or less. What about like the Bezos? He gets away with only paying 1% tax for his business, probably a 0% tax personally. Why is nobody taxing him? Why is nobody taxing Harvard or one of those schools? I looked into
Okay, so living in this neighborhood and having 4 athletic kids, coached a lot of kids from, you know, Newport on the other side of Irvine,
Yeah.
you know, Dover Shores. Okay.
Yeah, I know.
And a lot of those dads, you know, they're all wealth managers and stuff like that. And we were having this conversation one day during a practice, there's some election going on. And I'll never forget, Ollie he like butts in, he goes, guys, rich people don't pay taxes.
Yeah, they don't.
It doesn't matter who's president. They find a way out of it. If you're going to charge them, they're going to move their business to Mexico. Or what he goes, rich people don't pay taxes. So just that, it sounds good, right?
It's that's the thing. That's why, like, I don't really care too much about political parties. I feel like they are the same. They say that they're going to do something different, and for the most part, there's been like some really dumb stuff done this time. There's stuff that didn't probably affect most people during the Obama administration, but like destroyed some small to medium-sized businesses then.
Okay, I got a plan.
Yeah.
Let's resurrect the Whig Party.
The Whig Party, yeah. Let's what was the guy, Ralph Nader? What was his party? When I was a kid, there was a third option. I was talking to my wife about it today. I was like, there's essentially two, is what she was arguing about. I'm like, there was a third when I was a kid. Ralph Nader was part of it.
Well, Nader, he's that
Green Party?
I think it was a Green Party.
There used to be like 4 or 5 of them, but none of them win. So
Well, if I was to characterize myself as anything, I think libertarian.
yeah, I thought about that for a while too. Here's the problem though, man. I do think the government does need to intervene in some ways, because I feel like if you don't stop some people's greed, like, so it's weird. I'm like torn, you know, like I am there with you. I think the government needs to back off a lot of things. But
the way we should do it is just incrementally do taxes. Not for the lower, but if you're doing a high-end business, like a multi-million-dollar business,
multi-billions.
Yeah, multi-million-dollar business. All right, not just a $1 million business, because those are going to get taxed as well, but not in increments.
In my lifetime, there was a politician named Jack Kemp, a former NFL player, and he's the one guy that I thought, okay, he has solved it. It just eliminate this income tax shit, and just everything is sales tax.
Yeah, that's what they do in England, actually.
Exactly. So if you're one of these wealth management guys that I coach baseball with, and you're gonna go buy that Lamborghini, maybe you can not, report all your income, but you're gonna pay the 7.8% on the Lamborghini. And I think Kemp was suggesting a national one of as much as 10%.
But get rid of the property tax and
well, no, he wasn't advocating for that. He was just saying, okay, if we get rid of income tax and we just tax, because honestly, like, if I'm not going to be spending my money and I don't need it, I'm just going to have it wired to the Cayman Islands or something. I'm not going to get taxed on it. That's what all these guys are doing. But if you go buy the $500,000 Lamborghini, at least that's 10%.
Yeah,
that's what I always thought.
Yeah, I love that stuff. I definitely think, though, if you eliminate income tax, you need to change property tax to lower it, because there are a lot of people, at least if it's a person's only home, like,
so the way you handle property tax is you don't have a variant tax.
Yeah.
You have a linear tax. So it's just one, you're paying one thing, it's that thing, it's not going to go up or down.
This is what's keeping us.
Property
tax is keeping us from moving.
Because
Prop 13 years ago, when I was a kid, basically limited how much your property tax can go up every year.
Exactly.
So if you buy your house, like let's say, for example, for $100,000, and now it's worth $1 million, you're not going to be paying property tax. Like let's say it appreciated in 10 years. That 10 years, you might be paying property tax on 150,000 or something. There's a maximum percentage that it can go up. So that was Prop 13. And that was the year that all of the school field trips ended. I totally remember it. I mean, we didn't have as many field trips at school because property tax is what, funds all of the school districts. Now, if I was to sell this house and buy a house for the identical amount of money, my property tax would probably triple.
Yeah. And
I can't do that.
Yeah.
My dad has a deal because he's a disabled veteran that he can buy a place and he maintain his property tax from when he bought the place in Vista back in '87, which is nothing. So that's the only way it would work for me, but he just doesn't want to do it. So
I think for people who only own one home, which that may sound like a lot because there are plenty of people who don't own anything, I think the property tax should be much lower than the people. There are a lot of people who own many, 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 many homes, and Like I'm living in an apartment right now. It's owned by a single private owner. There's 26 buildings in my complex, and each building has 12 different apartment units, or sorry, 24 because it goes up to X. So I mean, you can already do the math. The minimum is $2,000 a month. It's super easy to see why somebody like him, yeah, he's going to get hit on an income tax, but he could deal with a little bit of property tax to help fund schools if they needed to. Because, you know, as I did the math, it was like $400,000 a month roughly. That's before your taxation. But yeah, I don't think anybody wants to tax everybody to death or tax the rich to death if you're thinking about this correctly, because then you also lose all your jobs. But we have to find a way to not let people pay 0% tax and try to tax the rest of the population. Like that's
Sales
exactly.
tax.
Exactly.
Sales tax.
Sales tax works. No, I think that's a great idea. They're never gonna. They don't want to do that. I don't know why. I think they get to all these other taxes.
Well, this is
Because we
why
get done-
I'm recommending resurrecting the Whig Party.
Okay, yeah, we'll do that, man. We'll have the Whig Party.
All right, guys. I'll see you tomorrow night.
I'll see you guys tomorrow. Or actually, will we
Professor,
do the test?
hey, Professor.
Yeah. Well, you got a question?
Yeah, our test is tomorrow, correct?
Yeah, test is tomorrow. I'll probably make it available at around 5. And then I'll be in the
Is there any-
room in case you need clarification on things or something.
Is there any way you can make it available earlier? I have work from 3 to like 10:30.
If I made it in time. I don't really sit on the turn it in late shit. I'm just trying to demonstrate, like, look, I did this, you know, and this number of people did it. So if you're having trouble with work or something, just turn it in late. You know, I'm just trying to see. If I get too online, I fall under online guidelines, which is trouble because then I have to, So sync remote is like this.
Yeah.
All right,
Okay,
guys.
so when would I be able to send it in?
Oh,
Later that
If
night.
we get stuck on any of the problems, we'll text each other back and forth.
What happens is if you turn it in late, it just says late. I get a lot of people that turn it in late because, like, I had this one girl in my math 30 class. I mean, she just is not smart. Like, she can't turn in her test, and I keep saying, I can't do anything for you. I can't come to your house. Look, I figured this out, and I'm an idiot. Like, so and then eventually she gets someone to do it. So I get it. Shit happens. Okay.
All right, guys. I'll see you, Eduardo. See you, Bobby. See you guys.
See you tomorrow.
See you guys.
Email me any integrals you need done.